Hi, quick lesson here on the equations of motion. We're looking at vectors again, and we're looking at adding vectors, but we're doing some calculations in this case. First thing, we start a task. I'll let you have a go at it. Pause the video. And there's your answers there. All the quantities in bold are vectors, and they're the only four vectors you had to know at National 5 level. At at higher level, you also need to know an extra two, momentum and impulse, but we haven't come across them yet. Okay, so today basically the difference in the learning intention from the last lesson is that you're adding vectors that are in a straight line and at right angles, but instead of just doing arrows, we're going to actually try and work out their magnitudes, and we're also going to try and work out their directions. Okay? First of all, we're going to start off with adding vectors in a straight line. So we imagine that a girl is travelling, running 4 meters to the right and then 3 meters to the left. There's two questions. First of all, what distance has she travelled? And secondly, what's her displacement? Well, we can represent 4 meters to the right with this arrow here, and 3 meters to the left with this arrow here. They're not to scale. The 3 meters arrow is a little bit shorter than the 4 meter arrow, but it's not meant to be to scale. It's just a representation. When we add these together, we would actually get two arrows that should be, if we're doing them nose to tail, tip to tail, we should get two arrows that are actually directly over each other, but that's kind of hard to see. So I've actually spaced them a little bit apart. I've lifted the 3 meter arrow slightly higher up here, so it should actually be right on top, but it's a bit easier to see. Okay, so we've got to add in now the displacement. Now remember, the displacement is a vector, so it's starting from the very beginning of the journey, so the end of this arrow here, and it's going all the way, but directly to the end of the journey. So it looks like this here. Remember, it doesn't care about how you get there. It doesn't care about the fact you've gone 4 meters to the right and then gone 3 meters to the left. The beginning directly to the end is your displacement. Now hopefully you can see from that the displacement is going to be 1 meter, and it's going to be 1 meter from the start to the finish, so therefore it's going to be 1 meter to the right. So the distance part, first of all, going back to the question, the distance part is just simply 4 meters plus 3 meters. It's just the distance travelled. She's gone 4 meters right and then she's run 3 meters left, so that's a total of 7. But the displacement is going to be 1 meter to the right. So that's basically from the start to the finish, she's moved 1 meter to the right. Okay, if we're adding vectors at right angles, it's a little bit more complex. And I've put on the right hand side of the screen the compass points. Now this is for a girl running 4 meters north, then 3 meters east. First of all, what distance has she travelled? Well, distance travelled, hopefully you can see, is the same as last time. It's going to be 7 meters it's going to be 7 meters in total. So that gets that out of the way. But what is her displacement? That's a little bit more tricky. So the first thing we do is we add the vectors nose to tail, as we did last lesson, as we did in the last example. Then what we do is we draw the resultant vector. And remember, the resultant vector doesn't kind of join up the triangle going around in this direction. It goes directly from the beginning to the end. So you're always going to have two arrowheads. The resultant vector and one of your vectors here is going to be, or your last vector here, the arrowheads are going to be kind of next to each other. Sometimes I do the resultant as a dotted line to make it a bit easier. So we have to use then Pythagoras to calculate the magnitude of the resultant. Now that looks really, really complicated because we're talking about Pythagoras, magnitude and resultant. Magnitude just means size. It's how long is this line? What does this line actually represent? And the resultant is basically just the vector that goes between the beginning and the end. Right, so that's the triangle again, and there's Pythagoras. So if we want to find the length of that side, it's x squared equals 4 squared plus 3 squared, and overall x equals 5. It's a 3, 4, 5 triangle. The second thing we need to do is to calculate the angle from the start. And we're always looking at the angle from that start position. So it's always the angle in the triangle that is next to the start position. We use trigonometry. So if we made that angle x, we called it x, then tan of x would be opposite over adjacent. Opposite is the one that is a side that is opposite this angle, and this is adjacent. Right? The reason we know that this isn't adjacent is because this is the hypotenuse. The longest side in the triangle, it's opposite the right angle, so this is called the hypotenuse. Taking that through, we get an answer of 36.9 degrees. I'm not going to go through the details of that because that's something you should have covered last year, but if you're unsure, then I can send you out the National 5 notes. The last thing you need to do is change the angle to direction. Now I have to say this is something that we don't often do at higher physics. You could be asked it though. This is something really we did much more at National 5 level. So in a sense, higher treatment of vectors is in one sense actually a lot lower level. We don't do this anymore. Okay, but you can be asked questions about forces where you do have to get angles, and you could be asked something that includes compass points. So the point is that whenever you're measuring an angle, primary school, secondary school, wherever it is, you're always measuring it from a line to another line. You're measuring it between two lines. So directions basically are measured from a known direction to the resultant. Direction is basically, if I just said 40 degrees to you, I mean, what does that mean? 40 degrees from where? You've got to have it from a point. Now, you can do it as a three-figure bearing, but I'm not going to talk about that at the moment. In this case, we're looking at the resultant, and we're measuring it from north. This direction here, up here on the left-hand side of the triangle, is north. Because this is going around here, and this is 36.9 or 37 degrees, to the east of north, because remember east is this direction. So we started off at north here. We're going 37 degrees round towards the east. Then I can say it's 36.9 to the east degrees to the east of north. Okay, try the examples on the classroom.